So how can we improve cars? We've seen how much energy they use. How can we make it better? Well, clearly electrification is going to be a large part of that. In a normal internal combustion engine energy car, 70% of the energy is lost as heat. There are things you can do to improve heat engines. A main one is running the engine hotter, which is what diesels do, but it's hard to get much hotter without causing nitrogen dioxide pollution and or melting the engine or having premature ignition. So that can get you maybe a few percent, but it's never going to get you a huge factor. Electric motors, on the other hand, as well as having no emissions, pollution, are more than 80% efficient. But this depends where the electricity to charge them has to come from. If it came from a low efficiency coal-fired power plant, they may be still quite bad. You just push the inefficiency somewhere else. Right now, the electric grid in Australia is mostly dominated by coal, and it's the same in many other countries such as China. So you could argue that there's no particular point in buying electric vehicles. However, a typical vehicle will be on the roads for maybe 20 years, and certainly well before 20 years the grid in Australia will be mostly renewable, and so the electric vehicle you buy now is going to be much more efficient in 5 years compared to what it is today. The problem with electric vehicles is the weight of the batteries. Here are some energy densities. This is a slide we've seen before. And what you can see is that a good lithium-ion battery stores about 1 megajoule per kilogram, whereas petrol stores about 50 megajoules per kilogram. So that means that you can get a lot more energy in a small petrol tank than a very large mass of batteries. Is this a showstopper? Well, let's look at the figures. So an average Australian petrol car uses about 375 megajoules per 100 kilograms. That's a bigger number than we showed before, but that's because it's the use of the car, not the car per person, and we were assuming previously 1.5 people in the car. So 375 megajoules, petrol's about 50 megajoules per kilogram, so that means you need about 7 kilograms of petrol to go 100 kilometers. Now, this would be a bit scary if you think about it in terms of an electric vehicle, because 7 times 50, because you remember 1 kilogram of petrol has the same energy as 50 kilograms of lithium-ion battery, so that would be 350 kilograms of battery just to go 100 kilometers. By the time you're going a few hundred kilometers, that means your car is going to be all battery. But it's not as bad as that because electric cars are much more efficient. As we've seen, they only need about 50 megajoules per 100 kilometers rather than the 375. And so given the battery storage of 1 megajoule per kilogram, that means you only need 50 kilograms of batteries. Now that's pretty heavy. I wouldn't want to carry 50 kilograms around, but it's not prohibitive. Given the car is 1,500 kilograms, it's only a small fraction. And so instead of putting 50 kilograms, you could put 200. It's still a small fraction, and that will get you a 400 kilometer range, which is typical of modern electric cars. And of course there are more savings because, sure, the energy storage is heavier, but a petrol car needs an engine to turn that petrol into motion, and the engine weighs a lot. They're huge, great things that fill up the whole front of the car, whereas the electric motors are much smaller and lighter, so you get a lot of the weight difference back. So in fact electric vehicles are typically a little bit heavier than internal combustion engine cars of the same size, but nothing dramatic. And of course electric vehicles have many other benefits. They don't produce the air pollution that's poisoning people, and they can power them off renewable energy. Modern electric vehicles have highway ranges of about 400 kilometers, so it's actually fine for long distance trips. I've gone on several long distance holidays with mine, as long as you have a charging station every few hundred kilometers. And typically it takes 15 to 20 minutes to recharge. Most of the charging stations are next to cafes, so you go in and get a coffee, and by the time you come out your car's charged up to 80% and you can keep going again. Many people argue that the most important use for electric vehicles to begin with is actually not for personal cars, but for delivery vans, the vans that go around and deliver your packages, or things like taxis, tuk-tuks, auto rickshaws in some other countries. Here's an example of a electric tuk-tuk that's being used by IKEA in Sydney to deliver stuff. Now, these are good candidates to be electrified because they drive many more kilometres. A personal car, normally you might drive to work in the morning, drive out in the evening, but it might only be in use of, say, 1 hour a day. But these delivery vans are driving around all day, every day, and so they rack up more kilometres in a year than a normal car might do in a decade. So that means if you can electrify these, you can make a big difference to CO2 with only a few cars. And the economics also works better for them because electric vehicles cost more to buy, but then cost less money to run because you save on petrol and maintenance. And for cars that run so heavily, that makes a bigger difference. It's more of a factor. Where electrification is going to be more difficult is long distance driving, in particular trucks. These are fundamental in many countries, including Australia, for delivering goods to most areas. In Europe, for example, the trucks are only 2% of vehicles, but they're responsible for 25% of the CO2 emissions. However, the technology seems to be there already. They need more power because they're heavier and have a bigger cross-sectional area, but current electric trucks have about a 400 kilometre range and can recharge in 45 minutes. Now that might seem a bit prohibitive, drive for 4 hours then recharge for 45 minutes, but actually that's what drivers are mandated to rest for anyway. So as long as the places they rest have recharging stations, it could actually work. A lot of infrastructure will need to be built to support this, but it's actually perfectly technically feasible. In terms of cost, this is a very low margin business, so even a slight increase in cost can drive a road shipping company out of business. But again, these are driven quite heavily, and so electric vehicles, right now, the total cost of ownership is probably more than that of a petrol truck. But by 2030, it's expected that the total cost of ownership of an electric truck will actually be below that of a petrol truck. They will cost more to build and more to buy, but the lower running costs will quite quickly pay that back. So I think this is also something that can be reasonably feasibly transitioned to battery electric in the next 10 or 20 years.